Hey everybody, this is Larry. This is day 27 of the March Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, join me on Twitch. Let me know what you think about today's poem. It's a little bit late today. The Google Code Jam is going on, qualification, so definitely check that out if you want more practice, if you want to feel not so smart, at least if you're me, go for it. And today's poem is Palindromic Substrings. Okay. Given a string, you're tasked to count how many palindromic substrings are in the string. The substrings are different. I mean, okay. So there are two ways, right? One is noticing that n is less than 1,000, so n squared is going to be fast enough. You just have to be smart about it. There's an n cubed solution, which is very, very naive. Of okay, given the starting index and the end index, is it a palindrome, right? So that's going to be n cubed. You could optimize it a little bit to n squared, which I'm going to do. But I also want to point out there is an O of n algorithm called the Manager's algorithm or something. I don't know if I've only read that word, so I don't know that I said it out loud. But I'll put up because I think that works. I don't know if that actually applies to this for counting, but in any case, it might work. Maybe we could go over it afterwards. I don't know, but I would also say that I actually get this question a lot about the Manager's algorithm, and like I said, I don't know if I'm saying it right, but if I'm butchering it, let me know in the comments or send me a link to how to pronounce it right correctly. But I do actually get a lot of comments about this algorithm because it does come up very randomly. It actually almost never comes up during competitive programming. I don't know if it comes up during interviews, but that said, that's why I don't know it. I'm not gonna lie, I don't know it, and I refuse to learn it because it's just so random, so like one-off. It doesn't really help you really build anything else. I mean, I guess there's some overlap with respect to learning, with respect to one of the string matching algorithms. Which one is the one of the failure function? KMP. Like it's kind of similar to that. Maybe it's also like you can think about it as dynamic programming. So there are ways to analyze it and think about it. But for me, it's just a little bit trivia, so that's why I don't think about it. Maybe if I could think about a way to learn it in a good way, then I will learn it. Because the thing is, right, like, and this is a little bit meta. Maybe I'll split this out into its own video at some point in the future. But some of it's just about meta strategy, right? And the meta is like, okay, look, you could like this is not a thing where you have to collect them more. At a certain point, how well you solve problems still matter, even if you know the solution, right? And what I mean by that is, there's your depth first search, your breadth first search, your graph algorithms, and all these other stuff is they're more fundamental, right? Or like, I don't know about probability, but let's say there's like a 30% chance you're going to see a depth first search problem or something like that, right? Well, then the question is, do you want to be average in depth first search, or do you want to be, do you want to be exceptional in depth first search, right? And my argument is that you actually want, for interview purposes, you want to be exceptional in you rather be exceptional in like 2 areas than being average in 20 areas, right? Because if you're average in 20 areas and you get an interview and you maybe average and maybe barely pass it, it's not going to cut it. It's not going to be exceptional enough, right? And that's my idea, my philosophy about stuff like the Managers, because it's like, in the 1% chance that I do get this algorithm, or it's not even 1%. I don't know. I know that it's on the internet somewhere that people have gotten this interview, but I don't know. I personally haven't heard any of my friends gotten it. So I don't know. Take it as it will. But in the less than 1% chance that you get this algorithm, I'm like, okay, sometimes you're just going to be unlucky in life and interviews and everything. So I accept that risk, right? I rather, if it's going to take me 3 hours to learn it, I rather spend 3 hours practicing something that is more likely to be asked and that I can, do very well in. That said, if you do happen to get this algorithm on an interview, even just solving it, you're probably going to impress someone. Anyway, with all that being said, I am going to try to solve this problem, the n square array. And the n square array is actually, it actually takes one observation, is that, you can build stuff from in or out. And if you build stuff from in or out, then you're able to, how to say this, like terminate early, right? Because basically the idea here is that, the idea here is that, okay, what do palindromes look like, right? Let's say there's, a even length palindrome. Even length palindromes contains palindromes in the middle. I think that's the key observation. And once you notice that, then if you start from the middle out, as soon as that is not, well, the two things. One is that you can terminate early, because as soon as that's not a palindrome, you could break early. So that's going to be faster, just, depending on your inputs. And then the other thing is that it's only over one extra time to expand outwards one way, right? We'll go over the complexity afterwards, and we'll go over the complexity. But that's basically the idea and the thought process on how to solve this for me. I know that I talked a lot, even because the code is probably not that bad, and you might be at home like already done with it. But yeah. So let's start. So let's do the middle is equal to in range of n, where n is the length of s. And then now we can, so now we have the two, the implementation is a little bit, I wouldn't say tricky, but you have to be mindful. So there are two different cases, right? One is, what am I going to say? Sorry, I got distracted. So there are odd lengths and even lengths, right? So let's, we can both go together. So yeah, left is equal to s sub mid, right is equal to s sub mid in the odd lengths one. So while left is greater than equal to 0, and right is less than n, and s of, oh, this is wrong. Oops, sorry friends, I meant this. Yeah, so right, we move left to the right ones, and then we move right to the ones, and then we increment count. And that's basically the odd lengths. And then the even lengths, well, it should be okay. We have to do an extra if statement of if it plus 1 is equal to less than n. And then now we have the same loop, really. And that's maybe it. Is that the only two test cases? I guess so. Okay. This is not an interesting test case, so we're gonna. Okay. If that passed, I'm okay. Unless this is a 0 case. I think we should pass the 0 case anyway. So that looks good. Let's give it a submit. Cool. Yeah, so let's go over the complexity real quick. This is O of n in terms of the loop. The loop will loop n times is what I mean. And then inside, this loop will also loop n times, because either left gets to the left first or right gets to the right first. But that's at most O of n. You should be able to, and from the same explanation, this is also O of n, because left goes to, either left or right will go, to the boundaries, and this will happen at most O of n times, right? So yeah, so this is going to be O of n, and because you have an O of n loop of 2 O of n loops, so this is O of n total, n squared total. In terms of space, I think we only have a couple of things, so it's just constant time. So yeah, so you have quadratic time, constant space. That's all I have for this problem. As I said, if you want to solve it, Google this, and maybe it helps, maybe it doesn't. Maybe it's worth learning anyway. Let me know what you think. And yeah, that's all I have for this problem. Have a good, whatever. Have a great weekend, actually. Weekend is coming up. There are a couple of contests coming up. Hope y'all will participate or just have fun. You can always watch me do it afterwards, because if you watch me live, then it's either really creepy or one of us is cheating. So yeah. Well, hope y'all have a good day, good night. Stay good, stay healthy, to good mental health, and I will see you later. Bye bye.